Hello, dear students. So, today we are discussing a small topic units. We come across so many physical quantities, and we are very much aware that for expressing any physical quantity, we need a proper unit. For example, if I'm talking about mass, then we can use the unit kilogram. Similarly, if I talk about length, then we use a unit meter. If I'm talking about time, then we use a unit second. So these are basic units, and we are having a system of units known as SI system, that is international standard. This SI means international standard of units. So these three physical quantities, as well as there are four more. So total 7 units are there. We sometime measure, you can say, amount of substance. Then our unit will be mole. The symbol will be MOL. Similarly, you can say there are more units like thermodynamic temperature. Unit is Kelvin. Symbol is capital K. We can say electric current. Current unit is ampere. Symbol is A. There is one more unit, luminous intensity. The unit is candela. Symbol is CD. Basically, we deal with these 6 units. This is not for use by students of class 11th and 12th, but you need to remember this one also. Then we are having two more additional units. First one is plane angle. Unit is radian, RAD symbol. Next one is solid angle, that is steradian. Symbol is SR simply. Okay. Plane angle, as you know, angle is defined as length of arc over radius. This is for 2D objects, and solid angle is for 3D object. Here we define angle as d ohm, and that is amount of area considered radius square. So these 9 units, if I call this as 8 and this as ninth, these 9 units are fundamental units. Okay? And using these fundamental units, we can define derived units, a lot of derived units. we came across so many derived units using some mathematical formulas. Like if I am saying, if I talk about simple speed, speed is given by distance traveled over time taken. Time taken. Distance we can measure in meter and time is in seconds. So the SI unit of speed is meter per second. You can say MPS, meter per second, or you can write meter second inverse. Velocity is displacement over time. Again, displacement we measure in meter, time in second. So this is again meter per second or meter second inverse. So look, these two, speed and velocities, they are different physical quantities, but they are having same SI units. So many times I came across like student is so much confused about state of an object. So what blender mistake generally student do? We know state of an object may be two, either it is at rest or it is in motion. Rest, you came to know if any object is not changing its position with respect to time, you can say that object is at rest. For example, you can see the lecture stand in your classroom, the benches in your classroom, they are at rest with respect to ground or with respect to a person on earth watching them. Motion means the movement of any object basically. Like here, object will change position with respect to with respect to time. Now, I just want to highlight one important concept. Like if you are focusing on, you can say, lecture stand in your classroom, is it at rest or is it in motion? So you have to be very much careful while you are giving some statement in physics. I can say the lecture stand is at rest with respect to ground, with respect to a person on earth observing that lecture stand, and that is not changing its position with respect to time. But same lecture stand, if observed by someone at like moon or at Mars or in space, then we know our earth is doing rotation, and rotation is a kind of motion. So this you need to convey to your teacher while you are answering your question.